Alright gang, here we are at chapter 3, and 3 focuses on motherboards. Now we briefly talked about motherboards in chapters 1 and 2. We'll hit on motherboards over and over again because they are so integral to the system unit. Now, objectives for this chapter, we're going to describe and contrast various types and features of motherboards, configure a motherboard using BIOS or UEFI firmware, maintain a motherboard, including updating drivers, flashing UEFI BIOS, and replacing the CMOS battery. We'll select, install, and replace a motherboard. Now, there are different types and features when it comes to motherboards. Motherboards, the most complicated computer component that we deal with. It's one of the first items to consider when building a computer because everything connects to it. It's the framework that everything is built on. The things we need to consider when purchasing a motherboard are the form factor, the processor, socket and chipset, buses and number of bus slots, and there's other connectors and slots and ports that come into play as well. Now there's different form factors, and a motherboard size and features are what make up the fact that it is a certain form factor. So they have to be compatible with power supplies, cases, processors, and the expansion cards. So if we're going to replace a motherboard, it has to be specific usually to that system. All right, most popular form factors that we'll see today are ATX, micro ATX, and mini ATX. Now mini ATX is smaller than micro ATX. That's also called ITX. All right, so I'll show you some different examples. So here's a mini ITX. It's quite small, and there's integrated components on the motherboard, whether it's sound, video, network, integrated in. So when it comes to motherboard form factors, here are the dimensions. Now, one of the things that we need to keep in mind is the holes in an ITX, or which a mini ATX. Those holes align with the holes in the two form factors that are larger than it. A micro has holes that align with holes for a full-size ATX. So that if the need be, we could, in some instances, use a smaller form factor in the same system unit. So we've got processor sockets. Now, that determines which processor a board can support. And it's not just the socket, but the board itself. It's only compatible with certain form factors, or with certain processors. Now, sockets for Intel processors, Intel makes several Titanium and Xeon processors that are designed for servers, and we've got to have the right processor for the right board. Right. So sockets and processors use different methods to make contacts between them. Now there's a pin grid array, or PGA socket, and the processor has pins sticking out of the back of it. There's a land grid array, and it uses lands or pads rather than pins. And then there's a flip chip land grid array. Now the chip is flipped over so that the top of the chip is on the bottom and makes contact with the socket. There's a staggered pin grid array, or SPGA, and the pins are staggered over socket, squeezes more pins into a small place. And there's a ball grid array, or BGA. It's not really a socket. The processor is actually soldered to the motherboard. So here's a plastic cover that would protect the socket when it's not in use. And we want to make sure nothing happens to these small little holes. So here's the retainer that will hold the processor in place when it is mounted. But if there is no processor, we have this little plastic cover to protect the grid. Now, We've got ZIF sockets, and that's all current processor sockets are ZIF sockets. And that's that little retainer that I showed you, and it's a side lever lifts the processor up and out of the socket. Now, sockets for AMD processors use a PGA socket architecture. Here we've got the different AMDs used and a description of the AMD chip. So 941 holes, 42, 05, 04. So each one you can tell by how many holes or how many pins it has on it on what type of processor it is. So given that they have different numbers of pins, they are not cross-compatible, meaning you can't use a processor that does not mount into a specific board. It has to match. Alright, so easiest way is to check with the manufacturer on what's compatible with the motherboard or with the system if it's a CAN solution or out-of-the-box unit. Okay. So, Intel chipsets use a north bridge and a south bridge. They use a hub interface, and all I/O buses connect to a hub. The north bridge is the fast end of the hub, and the south bridge is the slow end of the hub. So when we look at it, here's the processor. We've got a memory controller hub, the north bridge. So there's the fast one, and the slower one being the south bridge. It all depends on what it is that it's connecting to. So we've got different chipsets that we could use in, or I should say that are installed in Intel. Okay. And here they talk about the different chipsets. I'm not going to dig into chipsets here because we've got a lot of documentation on them. Okay, let's get to buses and expansion slots. The system of a bus is a system of pathways used for communication. Now, what does a bus carry across it? It could carry power, control signals, memory addresses, or data. Now, sometimes they're called data bus. Data and instructions exist in binary, and there's only two states. It's like a little switch. It's either on or off, ones or zeros. Data path size is the width of a data bus. Examples, the 8-bit bus has 8 wire lines to transmit. So here we are, and we're looking at the memory and the CPU. This is an 8-line data bus between the CPU and the memory. Now, there's a system clock that times activities on the motherboard. Now, we've got a speed of memory. There's a front side bus, processor, or other components. That speed of memory is measured in hertz. Now, hertz is 1 cycle per second, or we say frequency. And we may have megahertz, which is 1,000,000 cycles per second, or gigahertz, 1 billion cycles per second. Motherboards can have more than one bus, and we'll look here at a list of the different buses. So here's the different buses, the bus type, and the data path in bits. So we've got a 64-bit PCI X, it's a local I/O bus type. We've got 32 address lines and can transfer or has a throughput bandwidth of up to 8.5 gigabits per second. Now this is substantial. When we get up to PCI Express, now it's version 4 is not yet released, at least at the time this was printed in 17. Got up to 64 gigabits per second for 16 lanes. Right, now you can get up to 32 lanes. You're not going to get 64 gigabits per second on 32 lanes, but if you get up to 16 lanes, you get 64 gigabits per second. Now, when it comes to expansion slots, the conventional PCI it's been improved time after time after time. They just keep getting better. And if I back up and look at this chart, these are all PCIs from here on, from PCI on up. We're looking at 6 different versions of PCI. So they're just getting better and better over time. Now, down at the bottom, we've got USB 1, 2, and 3. Now, it's an expansion bus, one data path, and it's a serial address line. We can get, depending on the version, 12, 480 megabits per second, 12 or 480 megabits per second, being 1.1 and 2.0. When we kick up to 3.0, we're at 5 gigabits per second. That's significant compared to other ways to connect to a system externally. All right. So a PCI-X, it uses 64-bit data path. The latest version's PCI-X 3, 4 is on its way. You'll see the two long white, these right here, to the far left are the PCI-X slots, and they can support PCI cards. All right, now PCI Express is not backward compatible with conventional PCI or PCI-X. Comes in 4 different slot sizes, X1, X4, X8, and X16. Latest version is PCIe 4.0, which doubles the throughput of versions 3.0. Now here we're looking at the different PCIe slots. Now these PCIe slots, you can see some of them are quite small. The PCIe 1 slot is maybe an inch long at best. And then as we step up, we've got the conventional PCI slot, and we've got PCIe 4 slot, which is not quite twice as long as a PCIe 1 slot. Then we've got PCIe 16 slots, which are a little bit longer than a conventional PCI slot. Now, some PCs and some laptops will have expansion slot, and depending on how it's set up, it may have a PCI slot that we can plug, I would say a little Wi-Fi card. Okay. So with this one, the example here in figure 3-23 is a little Wi-Fi card. It's a mini PCIe slot, so it's got the wireless mini PCIe card that's installed in it. You'll see 2 wires that are connected to it, and those are the antenna wires. Now, sometimes, depending on the case itself, how this is configured, there are options to where we can have a PCI riser, and here's an image just depicting a PCI riser card, and then it's a right angle or 90-degree turn, and you can then plug in the PCI card, and it doesn't stick out as far as it would if it was plugged straight into the board. So a low profile or slimline case may require these. So we've got onboard ports sometimes, and over time components have been more and more integrated into the motherboard. They're USB, sound, network, firewire, video, eSATA ports. Now, older motherboards might have mouse and keyboard ports, parallel and serial ports. Now, we've got USBs replaced a lot of that today. And it's just because of how fast it is compared to those as well as the size of the port. So an I/O shield is a plate installed in the computer case providing holes for onboard ports. So if we're going to, excuse me, let's jump on. Internal connectors that we may have could be SATA, USB, or FireWire connectors. Now to configure the motherboard, we've got different settings. We can enable or disable a connector or a port, set the CPU frequency, system bus or other buses, control security features like as a password set on the BIOS, control what happens when the PC first boots. Motherboards may use different types of firmware, a BIOS, UEFI, which replaced BIOS, and UEFI with BIOS, which allows us backward compatibility. Now, you access the BIOS setup program, press a key or combination of keys during the boot process. Now, depending on the manufacturer, it depends on what the key is, when, how. We'll traditionally just hit F12, and that'll give us a prompt to where we can get where we need to be. So here's an example of a BIOS setup main screen. And we can see some information here. We can tab over to configuration, performance, security, power, boot, or get out and exit it. Okay. So this is, at a glance, like a rough layout of how the system's configured. This data is stored on the motherboard and a ROM chip. Now in UEFI, we've got it stored on the hard drive. But on these BIOS systems that we're looking at here, it's stored on the board. Now this then guides the system in how to start up, where the information is, where the connections are, and how to talk to them. Okay, you can change the boot sequence. Let's say that something happens and your OS becomes corrupted. As long as you put that DVD in the DVD player and you can boot from that DVD, most of the time you can repair the problem doing a reinstall or a repair using that DVD. But you have to boot to that first prior to trying to boot to the operating system, because if you keep booting the operating system that has failed, you're not getting anywhere. Now, move on through BIOS. Now, a BIOS has support for virtualization. We've got virtual machine software that we actually use that in our class on a Windows 10 machine. Virtualization has to be enabled in the BIOS setup. Is there LoJack for laptops? Now, there's technology embedded in the BIOS of many laptops to protect the system against theft. You must subscribe to a service. The software and the BIOS work together to locate the laptop whenever it connects to the internet. Now, there's drive encryption and drive password protection, which protects, you set password to protect those items. Nobody else can get into them. Okay, so here we are. We're on the exit phase. We can exit saving the changes, exit discarding the changes, load the defaults, load custom defaults, save custom defaults, or discard any changes. Now, UEFI. It's an extensible firmware interface. The original version was first developed by Intel and improves on BIOS because it's faster and better booting, mouse-enabled interface. That BIOS, it's just keyboard, no mouse, secure boot, and support for hard drives larger than 2 terabytes. Now, it provides a BIOS the ability to boot through its compatibility support module. Now, what that means, motherboard is considered a field replaceable unit. Now let me back up. What that means is that in UEFI, we boot to the hard drive data that's on the hard drive and not the motherboard. Not. Okay. Now we can update drivers. We can update the BIOS if we want. We've got to be real careful, given that the motherboard controls everything. It's like doing brain surgery if we want to talk about how extreme or how sensitive making changes to the motherboard are. If we make a change that alters the ability for this motherboard to function, we could have taken out the system, and sometimes it's cumbersome repairing an issue in the BIOS if we've done a bad flash on it. Now, we've got 32-bit drivers that work with a 32-bit OS. 64-bit drivers work with a 64-bit OS. Now, it depends on the motherboard and the OS, and everything's got to be compatible. Now, sometimes there's a jumper, and it's a small little connection, almost looks like a tiny little Lego. And there are usually two wires or pins sticking out of the motherboard. A jumper will slide over the top of the two and make a connection between the two. Now, when the jumper's in place, the connection exists. When the jumper's not in place, there is no connection. Now, sometimes I can pull a jumper out, and that will reset security settings and say, well, there's not going to be any password protection on the BIOS. All right. You can clear a forgotten supervisor password or a power on password. We'll probably talk about jumpers a few times later on, because jumpers are used in a number of different places. Now, the CMOS battery, it's a small little battery. Depending on the motherboard, some of them are real easy to pull out. Some are a little more cumbersome. We don't force them out. It stores power to retain that CMOS or that BIOS information on the board. Okay, now, there may be a time that you've got to replace a motherboard. Now, if you've got to replace a motherboard, you've got to figure out, which one do I need? The first thing we've got to think of is, who manufactured this system? Is it a one-off that somebody built themselves, or is this something that's an HP, a Dell, or something else? If it's an HP, a Dell, or whatever else, I need to go to the manufacturer's website and find out what is the motherboard, and they'll have all the specs there for it. So there's some research that we'll get used to doing over time. Find out what kind of processor's on it, and can we replace the processor? We could find the chipset and memory speeds that the board supports. Check and find out about expansion slots. Can we get a board with more on it? What hard drive controllers exist? Will it be compatible with the case? How much does it cost? Is there a warranty? And is there support for it? Now, how do I install or replace a motherboard? Now, there's a couple of schools of thought. One is, I need to pull the power supply out and get it out of the way, so that I don't have any confusion and I don't overlook any screws that may be holding something down that I need to remove. So when it comes to the power supply, there's usually only 4 screws holding it in place, and those power connections you should be familiar with. If you're going to change the motherboard, you should know exactly how to install it and remove a power supply. Now, having known that, we'll pull the power supply out. We've gotten familiar with the features. Maybe there's some little nuances that are specific to a certain case or unit. Do a search and find out. See if somebody's created a video already explaining, because sometimes there's little tips and tricks that you may not know about that'll help you get through what you've got to get through. So once we've got the motherboard out of the way, we'll remove whatever other items are connected to the motherboard, or I should say the power supply out of the way, remove whatever else is connected to the motherboard, and then we will remove each one of the screws holding it in place, and each one of the screws may have below it a standoff. And it's like a little washer that keeps it up where it's supposed to be, away from the metal case. Now, on the bottom of the motherboard, there are little solder connections that connect pins on the components of the motherboard to the board itself. Now, those solder connections cannot touch any metal. We don't want them grounding out. They could cause a fire, could short out everything that we've got. So these standoffs are important. So we need to note where the standoffs are and the screws that they're associated with. So we've got to document what we're doing as we go. Now, a smartphone is a great resource. We could be taking pictures as we go so that we put it back together the exact same way we took it apart. And when it comes to a laptop, it's a little bit different because now it's not as easy to open the case. The case may have a number of screws. And when it comes to laptops, sometimes the laptop, you may have to remove the keyboard to undo some screws just to get this thing open. So here's the steps that the authors got. And when it comes to motherboards, it's the most complicated of all components inside the computer. Most of them are going to use ATX or micro ATX. We'll see mini ATX from time to time, mini ITX. The motherboard will have one or more processor sockets. The chipset is embedded on the motherboard. That determines what kind of processor memory is supported. We've got different buses: PCI, PCI X, and PCI Express. We talked about how to change the CMOS battery. There may be a manual. There's always documentation when it comes to these systems when we look online. So be sure to go over all the videos in the labs in the course. When you've got questions, ask them early and often. And I'll see you in the next